In this video, we're going to go over Unit 1, Lesson 1, which is about simplifying and writing algebraic expressions. We're going to actually start with an example. So I'm using Greek symbols here. A lot in this class we use X and Y. But just for the first example, I wanted to use something really unfamiliar to show the point that it almost doesn't matter what the things are that you're combining. When you're simplifying, you're just looking for like terms to combine. So I see this Greek symbol. I see that I have 7 of them, and later on that I'm adding 2 of them. And so I can add 7 plus 2, and I get 9 of them. And it almost doesn't matter what the them is. In this case, it's the Greek letter mu. Then I see that I have 3 of this other symbol, and later on I am subtracting 4 of that symbol. So if I have 3 of them, positive, and I am subtracting 4 of them, then I have negative 1 of them that remains, and you could include the 1 in front or not. If there is no 1 shown, then it's assumed that there is only 1. So I can go ahead and make that look even simpler by writing it without the number 1 in front. And then I see something a little bit different here. I have parentheses, a number 7 outside of a parentheses for 2 beta. And that parentheses there means multiply, the number that is outside, touching the parentheses, distributed through what's inside. So 7 multiplied by 2 betas would give me 14 betas. 7 times 2 is 14. And then I see at the end that I am subtracting 3 beta. And so I have a little bit more to simplify. So I see that I've got this symbol and this symbol as like terms. So in the end, I'm looking at 9 mu minus 1 of these, and then 14 minus 3 is going to be plus 11 of these. And that's as simple as it gets, because what we're left with is symbols that are not the same as each other and do not combine. Another example of this involving more familiar variables, we have x's and y's. In this case, we actually have x squareds and y squareds. I'm looking for something to combine with a 7x squared, and I see later in the expression a minus 4x squared. The x squared there is just the name of the thing. It's really to count up how many you have that we care about. So I've got 7 of them. I am subtracting 4 of them, which means that I have 3 of them left. And you just leave the x squared as an x squared. Remember, thinking about that as just the name of the object. It's 3x squareds. And then I have, changing colors, 3y squared and a 2y squared that I'm adding together. And so this is going to give me plus 5y squareds, again, not changing the y squared at all. And that's the final expression, because now I have 2 things that cannot be combined, x squareds and y squareds. So to get some of the vocabulary defined here, what we're talking about are algebraic expressions. Everything we've looked at so far is an algebraic expression. It's something that consists of numbers, variables, operations, and grouping symbols. So something like 3, and then in parentheses 2 plus x. We've got all of the above here. We've got numbers, right, the 3 and the 2. We've got variables. That would be something like an x. Variable meaning it could vary. It could be anything. We've got operations. So an operation is something like plus or minus or multiplication. And then grouping symbols. So these parentheses are grouping symbols. Because it's grouping together the 2 plus x. So this is an example of an expression. You don't actually need to have all of these things. Even something as simple as just 3x could be called an expression, right? It doesn't have grouping symbols per se, but it is an expression. Or even just something as simple as the number 3, right? It has at least one of those components, and that would be considered an expression as well. So there's lots of ways that expressions can look if it includes any of those elements. This is a table that is from our textbook, from the Hayes textbook. So if you're looking for a one-stop shop where you can find the definitions of all of the terms from this lesson, you can find them in our textbook in a section called Background Knowledge 2. But we are going to go through and unpack a few of these on the following slide, so you don't necessarily need to pause on this slide and write down all of these notes. So one of the things we want to go over is the difference between an expression and an equation. An algebraic expression does not include equal signs. So in this true-false here, the first one says true-false, 5x plus 2 equals 4 is an expression. This one is a big false because it has an equal sign in it, and that makes it an equation. So if you want to see that word written out, an equation has an equal sign in it. An expression does not. So the second example is true. 14 minus x is an expression because 14 minus x is a combination of numbers, operations, and variables that does not include an equal sign. A few more terms to define here. The parts that are added or subtracted in an expression are called terms. They might be variable terms and they might be constant terms. So in the example that is here, this example, we have 3 terms. this one, and this one. Those are the separate things that are being added, or the parts that are being added or subtracted. So they have plus signs and minus signs between them. That's what separates terms from one another. And none of them can be combined with each other because they are not what we would call like terms, which we'll define on the next slide. So we've got three terms here. A number that is multiplied by a variable is called a coefficient. So a coefficient is going to be something like this 4 or this 3 because they are multiplied by a variable. So they are just part of one term, right? The 4 is part of the term 4x. It is the coefficient of that term. The 7 is not called a coefficient though because it's not being multiplied by anything. It is just a constant, meaning it is constantly the number 7. It's never going to vary, so it doesn't have a variable with it. It's just the constant term 7. And these other two terms are called variable terms because they have a variable in them, and each of them has a coefficient as well. Like terms, as promised, are terms that have the same variable and same exponent. Exponent is the little number that's written, let me arrow back a slide so I can show you what an exponent is. The little number in here, this is called an exponent, and if you see two terms that have the same variable, same exponent, then they are like terms and you can combine them. Constant terms are also considered like terms. So to simplify an expression, we combine like terms, and we actually started with two examples of doing this, so now I'm just going in and filling in the definitions for you. So you can combine like terms by adding coefficients. So for example, if you had this expression, I'll write a pretty easy one. We've got 4 terms all together. We're looking for any like terms that can be combined. So again, if it's the same variable and same exponent in the term, so in this case I've got the variable x, which has just an exponent that is 1, that's why it's not seen. I can combine those two terms. They're both positive. I can combine them to make 7x. And then over here I've got like terms as well because as I wrote above, constant terms are considered like terms as well. These are both constant and you can combine them. So I have minus 7 and then I am adding 2. So that's going to give us a minus 5. And then I have to stop because a 7x is not a like term with the constant number 5. So I'm going to have to stop short of combining those because I cannot simplify it any further. So for a few more examples, I've got another simple one, very similar numbers to the example I just did with p's this time. I'm looking for like terms. I see I have a 3p and later on a 5p. So that's going to give me an 8p. And then I see that I have a minus 2 and a plus 7. And those are both constant terms, which I can combine together to give me a positive 5. And that's as far as I can go, simplifying that expression. And then in the next line, I'm going to have a few different x's here that can be combined, but we need to be careful about this because our definition of like terms said you have to have same variable, same exponent. So I see this term, which has an x as the variable and a 2 as the exponent, and I need to find another term that has the same variable, same exponent, and that doesn't appear until all the way over here. So even though the other two terms have also x's in them, I need to find another term that has an x squared, or an x with an exponent of 2. So those are the two terms I can combine. I have positive 2 and I am subtracting 5. So I'm looking at negative 3 of that term. So negative 3 x squareds in the end. And there's nothing else I can combine with those. Then I see that I have a plain old x and another minus 9 plain old x. So I have a power of 1 or an exponent of 1, and that means I can add them both together because they're same variable, same exponent. I have 1 of them, I am subtracting 9 of them, and so in the end I have minus 8 of them. And then I have this one lonely term over here with the letter y in it. There are no other y's in this expression, and so that plus y just hangs out at the end with no like terms to be combined with it, and that's as far as you can go. So please note for yourself, you cannot combine by addition, right? You cannot add or subtract. That's what we're doing with our simplifying here. We're adding or subtracting. We cannot add or subtract unlike terms. So if they have different variables or different exponents, you cannot combine them. You have to leave them as separate terms in your answer. It can get a little bit more tricky when you start putting grouping symbols in there. And in this case, we've got grouping symbols called parentheses. that are around some of these expressions. And as I mentioned earlier, if you have a number touching a parentheses, it does mean multiplication. So in this case, the 4 is being multiplied through the parentheses. This is called distribution in algebra. So we're actually going to take this 4 and distribute it. It would be like if I came into a classroom and distributed 1 bottle of water to each student in the class. I'm going to take this number 4 and I'm going to distribute it to each term in the parentheses. That's what the word distribute means. So I'm going to take the 4 and distribute it through the x and the 5 because those are the terms that are inside. So each term gets multiplied by 4. So 4 multiplied by x is just 4x. There's nothing more simple to do there. And then 4 multiplied by negative 5 is negative 20. Over here I have a 3 that is getting distributed. It is a positive 3. So I'm going to take 3 multiplied by x, and I'm going to take 3 multiplied by 6. So now I have distributed and gotten rid of the parentheses, but now I have to look for some like terms to combine. So I see that I have a 4x, over here I have a 3x. I'm going to be able to combine those to make 7x. And then here I see I have a minus 20, that's a constant term, and a plus 18. Both are constants, which means I can combine them, and a negative 20 plus 18 is a minus 2. And that's as far as I can go with this expression. The next one has a little added trick to it. So the first parentheses has an 8 that is being distributed through. So 8 multiplied by d plus 8 multiplied by f. The second parentheses has just a negative in front of it. So this is when it's actually helpful to write in the number 1 for yourself. So I said you don't have to show a number 1 in front of things, but here you can help yourself by remembering there is a negative 1 there and multiply. Negative 1 multiplied by f is negative f. Negative 1 multiplied by negative d is positive d, because a negative times a negative is a positive. And now I've got my parentheses gone, and this is when I can start looking for like terms. So please note, we need to eliminate parentheses before we add and subtract like terms. So we eliminated our parentheses by multiplication. Now we're looking for like terms, and I see an 8d and a regular plus d, and that's going to give me 9d. And then I see I have an 8f, and I am subtracting an f, which gives me 8 plus 7f. Cannot combine d's and f's, so that example is done. Now on to the second half of the notes, and in fact it's less than half, it's the last little bit of the notes. There is a section about writing mathematical expressions, or algebraic expressions, in our textbook. This table is also from our book, again from the background knowledge section, background knowledge 2. And it defines some math vocabulary in English, so sum, difference, product, quotient, and even mean are some vocabulary words you should be familiar with. They are indicating different operations in math. So sum means addition, difference means subtraction, the larger one minus the smaller one in particular. Product means multiplication, quotient means divide, and mean means average, or add them all together and divide by how many things there are in the group. So we want to be able to take some written expressions and turn them into algebraic expressions using symbols. So we just want to practice reading it, checking the table if we're not sure what the vocab word means, and then writing it in mathematical notation. So the sum of 6 and a, we want to look back and notice that sum means addition. So to write that using math symbols, it would be 6 plus a. And the next example is difference between c and d, where d is greater than c. So this symbol means is greater than, or you can think about it as it is eating the bigger number. So the open mouth is facing the d. That means d is bigger. So d is greater than c. Well, if d is greater than c and difference means subtraction of larger minus the smaller, then I want to write this expression, the difference between c and d, as actually d minus c, because it told me that d was the larger one. And then the final example, the mean of P, Q, and R. If we look back at our table, we'll see that mean means average, or add them all together, and divide by, I use a fraction bar to show division, the number of terms that there are. You might also write that as P plus Q plus R, showing that you're adding them all together, and then divided by 3 this way if you don't like to use the fraction symbol, but you'll see me most commonly use the fraction symbol to mean divide. It's another way of showing a grouping symbol. So if you put a big fraction bar underneath an expression, it means that that expression is in parentheses. They're just not shown. They're invisible. But it's implied that you need to do that first, and then do the fraction or the division by whatever is on the denominator. And then just a little bit more practice. Convert these into algebraic forms. So we're looking at 18 more than a number. So this is not from our table. We just have to think a little bit about what we know about English language. So 18 more than a number would mean to start with a number. And you can use x, you can use n, you can use p, but use something general that could stand for any number. So something like x. And then more than that means addition, right? 18 more than that number. What about 7 less than a number? Well, then again, we want to start with a number and take away 7. So it is important to start with the number and then figure out what you're doing to it. And when I say a number, again, use any variable, x, n, p, the first letter of your name, whichever letter you like. That's going to be our general form of number. I'm going to keep using x. The next example says double a number. So I'm going to take a number, as I've said, try to start with that. And then to show that I am doubling it, I could write times 2, or I could add it to itself. So we've got a couple of options for that. I'm going to go ahead and show it as times 2 by putting a 2 right in front of my x, knowing that the number touching a variable does mean multiplication. And then finally, double the sum of a number and 7. So the sum of a number and 7 is then being doubled, is the idea here. So sum, I remember, means addition. And I need to write down the sum of a number and 7 first. So a number and 7 has a sum, looks like that. And then I need to double that. So somehow I need to get 2 of those on the page. So I can add another x plus 7, or I can group it and show that I am doubling the entire quantity in parentheses. And that's about as tricky as that's going to get. And that is all.